Good morning, everyone. Welcome to the first in a series of timber-focused webinars being supported by partners including the Construction Scotland Innovation Centre, Edinburgh Napier University, Scottish Forestry and Confor. My name's Sam Hart. I'm an Innovation Manager at the Construction Scotland Innovation Centre. I'm delighted to be joined today by Professor Robert Heston and Wojciech Plawas. Robert leads the research team, including Wojciech, at the Centre for Offsite Construction and Innovative Structures at Edinburgh Napier University. Before we get fully underway, we've got some housekeeping points to help the webinar run as smoothly as possible. Firstly, the session is being recorded today, just to let you know, and will be available on the CSIC channels and will also be sent to all the participants following the event. Everyone will be on mute for the duration of the webinar, but I do encourage you to please ask questions throughout. To do so, click on the questions in the control panel, type in your question and then press send. We'll try to get through as many as we can during the Q&A session later on. Your feedback and opinions are extremely important to us, so we will note each and every question, and if we don't have time to get to them all today, we'll endeavour to incorporate them into future presentations or communications after the event. We'll have some interactive polls displayed on your screens in between each of the segments today. Please answer them and we can then display the results for everyone to see during the webinar. And this will also help inform the direction of travel for the project we're going to speak about. And finally, I hope everyone has seen the links to the various handouts from Robert and Wojciech that's been made available. Please download them, use them however you choose. They're full of cutting-edge research that realistically are unlikely to find anywhere else. As you see from shortly from the presentations, the Research Centre really is forging the path in terms of timber engineering, and more specifically timber engineering using homegrown Scottish timber. You'll have noticed that the title of today's webinar is the Mass Timber Alliance webinar. The Mass Timber Alliance was formed as an output of the commercialisation of mass timber collaborative project between Scottish Forestry, the Construction Scotland Innovation Centre and Edinburgh Napier University. It's a collective of mutually benefiting partners collaborating to promote and upscale the mass timber agenda, not only in Scotland, but across the wider UK as a whole. As the first country in the world to declare a climate emergency, Scotland aims to become a global exemplar for climate change reduction, and the project was developed with this in mind. To support it, we've engaged the best academic and industry talent to accelerate change in construction culture and delivery methods, whilst utilising our sustainable and renewable resources. But that's enough from me. So to kick us off, we'll have the first poll that's looking at mass timber systems in a Scottish or UK context. So, which homegrown mass timber system is most suitable in the UK or Scottish context? So there's the results, and no huge surprises. Cross-laminated timber leading the way there, followed by glulam and dowlam jointly, and then finally nail lam, with no votes for laminated veneer lumber. Okay, thank you very much. Kicking us off, our first presentation today is from Professor Robert Heston. He's going to give us an overview and update of the work being carried out by his research team. Robert, over to you.
Hi there, I'm Robert Heston, a Professor in School of Engineering and the Built Environment at Edinburgh University, where I run a research centre on offsite construction and innovative structures. And welcome you here today as part of the Mass Timber Alliance webinar. We undertake leading fundamental and applied research for industry, government and public sector bodies in the thematic area of industrialised building systems, with a focus on the utilisation of timber. We do this through undertaking core and basic research, applying that into the sector in order to create impact, and we engage externally with both industry and stakeholders in that regard. Importantly, we map student talent onto this through the Built Environment Exchange Programme to, of course, accelerate their careers, but fundamentally to accelerate cultural change within the sector. We don't do our work in isolation, indeed we do it in collaboration, both externally and indeed internally. And with respect to this project, the Mass Timber project, we work closely with the likes of the Centre for Wood Science and Technology, given that they undertake the research work to understand the properties of wood, the influence of silvicultural practices, and what this means in terms of grading rules, etc. By us interfacing with that work, we can look to add further value to the resource through such things as engineered timber products and indeed mass timber systems. We have a back catalogue of work in this regard, and indeed we work across the varying systems in terms of panelised, volumetric, hybrid and sub-assemblies, and we've worked a great deal with mass timber systems, both in terms of homegrown mass timber products, where we've even pilot manufactured and tested these products and indeed utilised them within showcase examples such as the Commonwealth Games Athletes Village. We've worked also with imported resources such as tulip wood and the American Hardwood Export Council on the Multiply project, which was exhibited at the V&A in London, where we undertook the quality assurance test work. And we've also worked with the likes of Carbon Dynamic on the Dyson Institute for Engineering and Technology, which used, of course, imported resource, but we provided a degree of engineering intervention with respect to the volumetric CL2 units that were to be used for that project. Importantly, we digitise a lot of this work. We harness our research in the digital environment, and indeed we have a strategic agreement with Trimble, and we have established a Trimble Technology Lab at Edinburgh Napier. And of course we exhibit this work publicly as well, with working with the likes of Architecture and Design Scotland, and of course we also publish this work through such publications as Mass Timber, an Introduction to Solid Laminate Timber Systems, and most recently Off-Site Industrialised Timber Construction, published by TRADA. So we work across a range of thematic areas: off-site productivity and capacity, human capital, skills and culture, mass timber construction, and indeed digitisation. And we do all this work with a large influence and to create impact into the sector with respect to the specification of contemporary timber technologies. Importantly, these thematic areas, of course, cross over each other, and if we take productivity and construction productivity and why it's stagnated, and of course we want to improve upon that through off-site and manufacturing approaches, but equally taking cognizance of the necessity of delivering this new built environment for such things as the growing urban population without impinging upon the environment itself through the utilisation of non-renewable resources. So of course using timber in this respect is beneficial as a result of it sequestrating carbon, whereby if we utilise mass timber products and systems, then we can lock more carbon into the environment and actually start to reverse the climate crisis. So we've worked across the varying mass timber systems in terms of both the glued and non-glued products, in terms of CLT, glulam, neolam and dowlam. And we have an awareness of this wider global market and the upward trajectory which has taken place in terms of European production output, and indeed the boundary conditions which are being pushed through the delivery of such projects as Mjøstronet, which is an 18-storey building in Norway which uses engineered and mass timber products for its delivery. So there's a huge opportunity which resides globally, and we'd like to see that take place in UK and ideally in Scotland. And of course, to mobilise this, we have to understand the investment model. We have to understand what's necessary to unlock that capital investment for manufacturing to take place, and of course integrate that with our available resource and select the right mass timber product to be utilised. So in this respect, we need to understand the demand, what that means in terms of the resource that's available to us, in order to unlock that investment potential, such that we get to the optimum point of this Venn diagram, with a view to the commercialisation of mass timber. So in this respect, we have mobilised this project, working with Scottish Forestry, the Innovation Centre and Clonfor, and of course ourselves as the academic delivery partner, and assembled a cross-section of stakeholders from the supply chain with respect to tap into their knowledge base as well. So in this regard, we have a series of work packages which we're working through, and today we will showcase those to you, and Wojciech will provide a wider explanation of the work that's been undertaken today. So with that, I'll hand over. Thank you very much.
Thanks for that, Robert. I think for me, the thing that clearly stands out most from that presentation is the sheer scale and volume of research going on at the centre, both in terms of the back catalogue and the current work being undertaken at the centre at the moment. Okay, on to our second poll, and this focuses on the primary markets for mass timber. So, which is the primary market for mass timber? And there we have some fairly close run results. Health and education coming out on top, just in front of commercial and office and multi-family, low level or low rise housing. There's some higher rise stuff there, and single family housing coming up at the end. So thanks very much for that. Okay, our second presentation today is from Wojciech. Wojciech's been the lead academic for the commercialization of mass timber project we highlighted earlier, and I'm delighted to welcome him to give us an update on the work that's been undertaken to date. So Wojciech, over to you.
Thanks, Sam. Maybe first things first, let's check the connectivity, if my screen can be seen by everyone. I would assume yes. Okay, so good morning, everyone. My name is Wojciech Płowaś. I'm a research consultant at the Center for Offsite Construction and Innovative Structures. My background is in structure engineering. I specialize in timber engineering. And for the past few years, my research focus was on mass timber systems such as CLT, double laminated timber, nail, and glue laminated timber. Well, today I will talk to you about the recent advances we've made in the last few months and in the research of mass timber systems. However, before I continue with my presentation, I would like to briefly introduce the research methodology that we adopted during the research of mass timber. So the research methodology first came to play when we were thinking about best ways of utilizing all the research information we have on file. So in a sense, it formed a platform to ensure the consistent reporting of all the available information. What it also allows us to do is to identify any gaps in the research. So just to quickly go through the steps adopted during the research. So the first step is the identification of the right mass timber product for the context. That includes reviewing its application and manufacturing process. Second step in the research is the preliminary investigations. This is where we're trying to get an understanding of the market and available resource, and also look at the characteristics of the raw material and potential adhesives or their joining techniques that could be used. The next step is the review of the compliance criteria. This is really to do with the assessment methods listed in international recognized standards. If the preliminary investigation is promising, the panels should and often are pilot manufactured. So at this stage, we make sure to follow the appropriate quality assurance during the stage, just to replicate the full-scale commercial production as much as possible. Finally, when the panels are manufactured, they are being assessed. So this is a form of primary investigation. This is where we carry out the tests, often in the lab environment, to evaluate its properties of the panels under investigation. We then use results obtained during the primary investigation to carry out the design and analysis exercises. So this is step 6, and during that step, you also carry out performance modeling and identify a best end use for the product. And finally, probably the most important step is the pilot project. So this is where we trial the product such as CLT on a real project, just to evaluate its feasibility for the full-scale production. And the last step is the future work. So this is to do with the ongoing research and optimization of a panel that's been developed. Okay, so why I was saying all this is, as I've mentioned earlier, we use this methodology as a platform to summarize all the research that we've carried out historically. And as a result, we've created these 4 documents. Each of them is to do with the different mass timber system. The full reports are not yet available. They will be in due course. However, for now, we've created an extract version, a shorter version of them, and which are downloadable during this webinar. So what kind of information can you get from them? For within each of the documents, you will see the list of the compliance criteria and assessment methods for each of the product. You will be able to see all possible configurations that we looked at. This is to do with the lamella layup and timber strength grade that could be used for manufacture. Also, there is a comprehensive list of all mass timber panels that ever been pilot manufactured, and together with the properties that were derived during the research, during testing. And to help you visualize the kind of content of the report, so this is the table summarizing the information of the research. In this case, that's a UK CLT made out of Sitka spruce, local resource. So the care was taken to create like a high quality looking document. So within this, what you can find for each of the panel that ever been manufactured, some geometrical properties, what adhesive was used, a little more information about the lamellas itself, so its grade, what was the width and the depth, as well as density and moisture content measured during the production. Finally, you will also see mechanical properties derived from testing. So in this is only one table. There's way more tables like that available within those documents. Although a lot has been done and we have good understanding of local resource and its feasibility to become a raw material for mass timber production, there are still gaps that will have to be addressed. And see in the table at the bottom, this is the estimated level of research that we think we are at. So we use the research methodology to try to quantify what should be done. And this is one of the reasons why, together with Construction Scotland Innovation Centre, Scottish Forestry, started this project, mass timber commercialization. So one of the reasons is also to close the gaps, but also to get full understanding of the feasibility, potential cost, benefits, constraints of mass timber manufactured in Scotland using a homegrown resource. So as Robert has mentioned, the project is split between 4 or 5 distinct work packages. So work package 1 is to do the parametric analysis of mass timber design and analysis exercises using the research data, so applying the results, updating what we know already, and extending the information we have. And this is also to do with the development of technical details. Work package 2 is the market assessment. So this is where we look at the potential costs of different mass timber products and how do they compare with the materials and products available on the market. What we also try to do via this project is to get an understanding of the current demand for mass timber products. Work package 3 is the manufacturing feasibility. So this is where we're going to create the case studies, cases for manufacturing scenarios. So setting up the manufacturing facility in Scotland. We're going to review the potential suppliers of the equipment, what equipment is necessary, and so on. And finally, is the work package 4, fabrication and pilot project. So what I'm going to talk today is the first two work packages. So we've carried out some parametric analysis, carried out some design exercises utilizing UK homegrown mass timber. I'll focus mostly on the CLT. Also, I'm going to close off my presentation with some information on market assessment. Okay, so part of work package 1, parametric analysis, was to create a series of optimized product specifications. To do that, we extracted the information in the 4 documents I've mentioned earlier and created an even more condensed version of a technical specification for a possible UK mass timber product. So in this case, it's a CLT. So the information you see in this table have been confirmed in many cases, been manufactured, and all relative to what we have done historically. Another part of the work package 1 and parametric analysis was to compare a potential CLT made out of UK homegrown resource and what's currently available on the market. So we've reviewed the literature. As a result of the research carried out by the center within our institute, we know that the UK Sitka spruce, which is the species most likely to become a commercial species, can grade to C24 in 25% of this 24 C24 and 75 remaining C75 is C16. So this can be achieved with a minimal amount of reject. So now the idea is how to best utilize this resource. So for that, we've created a series of hypothetical panels, let's say, made out of UK homegrown, that one day might become a homegrown CLT. And in order to best utilize the material, we've introduced 2 types of the material. One being the homogeneous, denoted by the letter H, and which contains only one grade, which is in this case C16, and what we call combined, which is consisting of C24 and C16. If you notice in this table, you can see that the C24, the higher grade timber, which is stronger and stiffer, is located at the top and the bottom of the panel, and there is a reason for that. It's being to do with the stress distribution when the beam is subjected to loading. So the highest stress concentration is always at the top and the bottom of the beam or panel. Okay. Also included here is the percentage of how much grade is being utilized. I'm gonna move on. I'm gonna carry on a little more. I'll tell a little more about this in a few more slides. Okay. So after creating a list of hypothetical UK CLT panels for comparison purposes, we had to develop a design spreadsheet to allow us to create almost indefinite types of panels with as many possible layups as possible. So we've done that. We are now in position of changing the layout the way we want, the way what market needs, and check its in this case just structural performance. So in first instance, just to check what we're dealing with, we've compared those three panels. First panel being a standard CLT, which is standard CLT usually consists of C24 high-grade material. We then compared it to C16 homogeneous CLT and a combined version of it. Throughout the research, it might not come as a surprise to anyone here that the most critical factors determining the design with the CLT, design of the floors, is either deflection of a vibration or a vibration of the panels. So this is the 2 properties I focused on because those 2 are the most often critical. So just to carry out the simple comparison, I created this span. So all those 3 panels were subjected to the same span and loading conditions, designed in the same manner. So if you look at the design output for CLT made of C24 only, it passes the design, but it's good to go. Using the same method for design of the CLT panel of the same depth and the same lamellas and the same configurations, we see that this panel would fail in vibration. However, if we change the top and bottom of the lamella to the stronger material C24, which will result in a 50-50 split between two timber strength grades, we will pass the design almost. And what you see the percentage here, maybe I should tell that earlier, is the utilization. So in this case, 94% of the strength is used to resist the vibration. It's almost as good as C24 only panel. Just for fun, or just to prove the point and check how spreadsheets can be used, we create an optimized version. So the panel depth is still the same, but what we've done here, we optimize the ratio of the different strength grades, and the result came up positive. Although, yeah, 100%, we passed the design, but this is just really for the demonstration. We probably wouldn't go with this panel. We would have to slightly increase the top and bottom. But this is just to prove that we can modify the layup the way we want. Okay. So another way of using the design spreadsheets we've developed is to create a span tables for those 5 different type of panels, which represent the UK span tables for the UK CLT. So we used the 5 different loading conditions for development of the span tables, and those are reflective to the designation of the building. So either single-family dwellings, hotels, offices, classrooms, and museums. So the list is longer, but this seems to be most appropriate for the context. So you will see in a few slides that we use those variable loads as a case studies. Few notes regarding the design for those of you who are interested. I'm happy to answer more detailed questions after the presentation, but for the purpose of this presentation, I added those notes. So in the design, we assumed that the timber is a service class 1. The slab is simply supported and bended about main axis, and only UDL is applied. Self-weight of the CLT is included. Deflection and vibration checks are carried out to UK National Annex to Eurocode 5. Okay, so using all this information, the list of hypothetical panels, we've created a span table. So what we have here is loading. So we've got the dead loads, 3 different cases for the dead loads, and 5 different variable loads. At the top of the table, there is a type of the UK CLT that we're looking at. Here is the ID of the panel. So the first number stands for the depth of the panel. The second number stands for the number of lamellas used, and H or C stands for either homogeneous or not homogeneous, as shown in this table. Finally, we have a maximum span in meters. What I've also added is the letter V or D, which stands for vibration or deflection. So this is the design output, and what's the most critical for this particular panel, whether it's a vibration or deflection. Okay, so we talked about UK homogeneous CLT only. Now we have a combined CLT. Again, the panels here consist with the list of the panels in the table. So we can see here that the span increased significantly. Just for full context, we also carry out using the same methodology. We carry out design exercises and created the span tables for C24 CLT only. At this point, you're probably looking and trying to compare the span tables. I would go through that as well, but I would try to make it easier for everyone. Because I crunched the information, crunched the data, and so how exactly does standard CLT made entirely from C24 compared to UK homogeneous and UK combined CLT? So after looking at the data, we've noticed a 9% reduction in span on average. The difference is 9% between C16 and C24 CLT only. In Another case, the combined CLT, there's only 2% reduction. Okay, so there's a few more slides left. So the second part of the project, mass timber commercialization, is to do with the market analysis. So most of you should be aware by now that we are doing this UK mass timber questionnaire. This is to help us get the input from the industry on what is the current demand, what are the barriers, what is the best product for the market, and to help us to analyze it and develop the product which is the most suitable. For those of you who still haven't carried out the survey, I would like to ask to do it, because the kind of information we get from you is essential. Okay, so the survey has been on for a while. I think we started it in February this year, and I want to show you some output we have so far using the responses we got so far. So this graph looks very similar to the result from our polls earlier today. So the cross-laminated timber has been identified as the most suitable mass timber for the UK, followed by glue laminated timber. Primary market for the UK CLT is identified as schools or educational, followed by multifamily housing and commercial offices. We also looked at key motivational drivers for different stakeholders in the construction process. So key motivational drivers for the investors, according to the results from our survey, is the reduced on-site labor, carbon sequestration, and sustainability. For the specifiers, architects and engineers, what seems to matter the most is precision manufacture and design flexibility. And for building contractors, no surprise, reduced on-site labor and the speed of construction seem to be most important drivers. So what this tells us is like now we can focus on those important things and try to address that to create a competitive product that will be desirable and reach the desirable market penetration. Finally, primary threats to the mass timber in the UK. Most of the responses seems to suggest that the building regulations are the biggest threat to the UK, followed by lack of knowledge on the material and the competition in the form of traditional construction. Okay, we also looked at, we reviewed the literature. We looked at portfolios of different CLT manufacturers from mainland Europe, and we reviewed the most, I think, CLT projects that's been carried out, in the UK in the last 15 years. So from this 500 CLT project, we've identified 20% that we looked closer at. So we try to get as much representative sample as possible. And after analysis of those 20% of CLT buildings, we identified that most CLT volumes being used for residential purposes, followed by educational and commercial. In terms of the elements, the building envelope elements that CLT is used for, it seems like the walls as the first choice. So the CLT was used mostly in walls, using to build walls, followed by roofs and floor, which is a good news, because the design for walls, at least from the structural point of view, is it's easier to attain using C16 only timber. Finally, using the sample we've selected, we looked at the height of the buildings that's been constructed using the CLT technology. So, so this is the graph showing the height of the buildings depending on the sector. So we see that the CLT buildings hardly ever go over 20 meters. It's more like averaging about 14%. I know this is a hot topic these days because the ongoing discussion whether to create the government is trying to suggest to really limit the height of the building made out of combustible material such as the CLT. So that's why we've created this table. So according to our sample range that selected for the analysis, about 50% of the buildings were constructed, were 11 meters or less, which means that if the legislation passed and the buildings over 11 meters made out of combustible material will be banned, we potentially could lose 50% of the market. Okay, that was me for today. Thank you very much. Hope I didn't take too long. I didn't check my time. Thank you.
Not at all. Thanks, Wojciech. That was fantastic. I hope everyone's now got a good understanding of the type of work that's being undertaken at Napier University. For me, I think the most important factor there is actually seeing the art of the possible in terms of homegrown timber and the potential value add that the mass timber market could offer to Scotland's natural capital. Our third poll today looks at the USPs associated with mass timber. So what would you consider to be the principal unique selling point of mass timber products? And again, no big surprises. 50%, so half of the audience think speed, accuracy, and quality is the key unique selling point, followed by the health and well-being benefits, followed by enhanced building performance detailing. Okay, today's final session is an opportunity to run through some of the questions posed by you, the audience, to the expert panel. First question I have, perhaps for Robert, or no, sorry, yes, let's choose Robert. How simple is the automation process if we're looking at combining C16 and C24 grade timbers in a manufacturing facility? I think you're on mute, Robert. Sorry.
Sorry about that. Made that mistake at least once a day, right? So so that's not, as you know, it's not currently common practice to have these types of layouts, but that's not to say that it wouldn't be possible, and certainly something that we want to do with respect to this project is indeed engage with some of the manufacturers to see what could be done with respect to that type of capability. And of course, there's things that we can do, as you know, at the Innovation Centre and via the Innovation Factory to perhaps trial some of this. And one of the aspects of that, and the work that we're doing through the sort of digitisation, as I explained, is when we create these digital objects of the mass timber products, and with an emphasis on CLT, is to build into that digital object relevant information with respect to the carbon credentials, ideally the cost, and linked in with that things such as productivity, and of course with respect to productivity and trying to manage the layups of the CLT in this regard, it would of course or it could indeed have a degree of impact on the productivity. So we would need to balance the structural optimization with respect to the resource and the understanding of the demand, with reflection on the manufacturing process and the types of intervention that would be required within that manufacturing process, such as automated layups, and what that would mean in terms of indeed the productivity and the throughput. But having said that, we're aware of where the bottlenecks as such reside within the CLT manufacturing process, and correspondingly, I don't envisage that being a bottleneck at that stage. The bottlenecks probably will come further down the production line in terms of the pressing or the CNC machining, etc. So there's definitely scope to work in this regard to look at whether we could have a degree of automation with regards to the layups in order to optimise the resource. But one of the barriers to that again would be circling back to the sort of regulations and the necessity for technical approval. So there's certainly things that we need to resolve, but what the work that Wojciech has done and certainly demonstrates is there's an opportunity there to maximise the potential of CLT relative to a resource, which, you know, circling back to the origins of CLT was what it was always about. It was about maximising the value of the resource within the built environment. So yeah. So, you know, just to clarify, we're aware that this isn't a standard approach, but we think there's definitely merit in progressing it with respect to a resource and where we think that the demand for the product would be within the market.
Brilliant, thanks. And linking into that, I guess, Wojciech, in your experience when you've been working on the UK timber, we've got a question here asking, what sort of wastage is there in regards to knots when you're looking at optimizing the UK timber? What's perhaps the difference between the European and UK wastage when you're going through, the optimization process? Mute again, Wojciech, sorry.
Unfortunately, I don't have an answer for that question just yet. We have carried out some research on drying and yields when seed castration is being dried, but this is the kind of topic that we're going to look in depth when we start working on the third work package, which is to do with the manufacture of mass timber, and the wastage will definitely be considered then. So all I can say at this point is stay tuned in, and we will definitely provide some update on in that field, because this is quite specific information required, which I don't have at the moment.
No, okay. I guess from a waste point of view, the idea would be from a manufacturing facility, there's the opportunity to incorporate that waste into, you know, the powering the facility itself and that sort of thing. So, no, perfect. Robert, then,
I was going to chip in a wee bit, because one of the aspects of that is also the sort of aesthetic quality. So whether it's industrial grade or whether it's exposed grade, so there's a number of things that kind of impact upon the level of wastage. And of course, one of the key things that Wojciech picked up on there was the target moisture content of it with respect to. And we do have that information on file as such, but one of the aspects of that is, you know, there's what you can do within smaller. It's kiln specific, right? So that, you know, depending upon the setup and what you're looking to do and at what scale, all influences the sort of level of waste, and indeed the level of or the grades, the aesthetic grade as such of the end product. So there's just a few nuances in there that need to be unpacked, as Wojciech to within the next phases of the project. But hence why understanding that where the demand sits in the market, and indeed the impact of regulations with that. You know, can we have exposed CLT as it is? You know, because obviously things like surface spread of flame and etc. and you know, all influences that. So yeah, we can be overly specific with this. What we would look to do is look at the level of variables that influence that, and correspondingly come out with an answer which would show the level of percentage waste relative to end application and aesthetic grade requirements, for example.
Yeah, perfect. Okay, I'm just got one last question here, because it links into potentially our next webinar, and also future projects that we're looking at. There's a question around, if we were to look at commercializing homegrown CLT and we want to service the UK market, do we have the forest stock available to meet demand? And I know you know, we've been speaking to Scottish Forestry around. Well, I suppose, I mean, it's for you to answer that around the potential value add and things like that.
Yeah, I think a straightforward answer to that is yes. You know, in terms of, you know, one of the things that we are looking at within this project is the relative scale of the facility. So in terms of available resource, there's available resource with respect to the scale that we want to achieve, to fit in with where the demand sits in the market. But yeah, there's definitely an availability of fibre which could be utilised for CLT. The current stats around utilisation of UK resource within construction are circa 20%. So there's another 80% that we could be adding further value to. And in that regard, it's thinking about, in line with the sort of paradigm of the circular economy, how we can maximise the value of a resource in order that we can sequestrate carbon for longer periods of time, and think of the lower value utilisation of timber at the end of life in terms of that circularity with utilisation of it for woody biomass, wood fuel as such, as near to end of life as possible. So in answer to that question, yes, there's definitely fibre available to manufacture mass timber construction. It just depends to what scale we want to achieve.
Perfect, brilliant. Okay, well, I think that's just conscious of time. That will probably see us through for the questions. We've got one final poll, if we can squeeze in, looking at the potential barriers to upscaling mass timber in the UK. Ooh. Not sure if that came and went or if it's up on the screen.
There are no barriers.
Let's go for it.
Yeah, it'd be good to try that. No.
I'll carry on. So I guess to wrap up, firstly, thanks to everyone in the audience for taking time to join us today and for all of the important questions. Thanks to the panelists, Professor Robert Heston and Wojciech Palas, for sharing their thoughts and that insightful discussion. I really hope you found the session useful. There have been a lot of questions submitted. Unfortunately, we haven't been able to answer them all. CSIC and the panel members will endeavour to answer them either in follow-up communications or within future presentations. We will be continuing these webinars moving forward. Your feedback will be used also to plan future ICON events and initiatives. So please, I'd really appreciate if you could complete the feedback form that you'll receive in with the email after the event. And also, please make sure you check the links in the chat function for any related sites. Stay up to date with the latest state of the art. And again, you can contact any of us through these links for any further information or references or papers that you'd require. So just leaves me to say thanks very much for attending, and we look forward to seeing you at our next webinar. Good afternoon.
Thank you. Thanks, Sam.
Thank you.